Oh, hi there, Twitch. How's it going? My name's Andrew
What?
Belney. We're here for Howdy Partner. I'm joined by my colleague Andrew up there. You've seen Andrew before if you've watched. And we've got two friends today that we're going to meet from Weaveworks, Daniel and Sebastian. I'll give them some time to introduce themselves in just a minute. But I wanted to give you a rundown of what this show is if you're tuning in for the first time. So you are now watching Howdy Partner. Welcome. It's the wildest show in the wilderness, I think. But really, what we're here to do is talk with AWS partners. So anybody who is in the Amazon Partner Network, or APN, you might hear it called. And today we're talking with Weaveworks, who build tools for working with Kubernetes, amongst a lot of other things as well. But I'm joined today with a co-host, Andrew Park. You want to tell us a little bit about yourself?
Hello. Yeah, so my name is Andrew Park, a partner solutions architect here with AWS, and I work with AM on working with our partners to highlight their technologies and some of the cool things that they're doing in the industry. So super excited to have Weaveworks here, and if this is your first time tuning into the channel, make sure to subscribe for updates. And today we will be talking about all things Kubernetes.
Yeah, and we do this show every Monday, every Wednesday at 2 p.m. Pacific. We'll be featuring new partners and some old familiar faces all throughout. I think all the way up till June, maybe into July. Who knows? We might go crazy.
Who knows, man?
I don't know. But if you have questions while we're talking, either Andrew and I can answer you in chat, or we can bring these questions up to our expert guests here. So please, if this is your first Twitch stream, AWS Twitch stream, if you're just learning technology, if you are an experienced, seasoned veteran of technology, feel free to watch and ask your questions. Maybe you'll learn something from Sebastian or Daniel here. But let's start with Daniel. Tell us about yourself.
Sure. Hey, and thank you for having us. I'm Daniel Lizio-Katzen. I lead partnerships and strategy here at Weaveworks. And prior to this, I was working at another startup called Galactic Fog, doing lots of fun things in serverless and containers, and have been doing cloud things since before the cloud was actually launched. So have a little bit of experience. I'm very, very interested in all things containers and serverless.
And Sebastian?
Hi, happy to be here. First time viewer, first time caller. And I'm a customer success engineer at Weaveworks. Before that, I was another lackey of Daniel's at Galactic Fog, where we did a whole lot more cloud-based applications. I am a software developer and systems analyst person at heart. I just love technology and continue to do it because it's fun. And I'm here to just talk about Weaveworks and our products and projects.
Cool. Thank you both for joining us. We've already got somebody doubting that we are actually live. It happens every stream. But I am new to Draw. We are live. Yeah, we are. We're here, right here. Ready to take your questions, too. I'm sorry I took too long to answer you. I was talking. Should have been chatting in chat. Sorry. But Andrew, you're gonna give us kind of an overview of Kubernetes and kind of maybe demystify some of this stuff. There's a lot that comes to unpack when you talk Kubernetes, I think.
100%. Right.
You want to kick us off?
Yeah, let's do it. So, in the industry today, Kubernetes is very, very, very popular. And, one of the common patterns we see with Kubernetes is the integration with Weaveworks, and which is why I'm super excited to have Daniel and Sebastian on the show today to kind of walk us through what Weaveworks can do for your Kubernetes applications and your workloads. But I think there's a lot of confusion around what Kubernetes is and kind of the problems that it solves, right? And then from there, what does that mean to then have like a managed Kubernetes service on something like AWS? So, for viewers, again, that are tuning in for the first time that want to learn more about Kubernetes and kind of what that means, I'll give you guys a rundown of kind of EKS, the problems that it solves, and some ways you can get started with it. And then I'll hand it over to Sebastian and Daniel to talk about Weaveworks and how you can use Weaveworks to simplify, using Kubernetes on AWS. So let's talk about kind of what Kubernetes is, right? I think that's one of the big things that people are still trying to figure out. So Kubernetes at a very, very high level is a container orchestration engine that allows you to effectively manage the deployment of containerized applications, right? And so this is very, very prominent and very, very helpful when you have thousands of containers that goes across hundreds of developer teams that also go across your IT operations teams. And as you grow as a company and as you scale, you need a way to orchestrate all of your containers so that one, you scale properly, and two, that things just don't break and crash and burn, right? Because one of the things that we typically see a lot in today's industry is that people will hear the term Kubernetes, right, and they'll see all the cool things that you can solve with Kubernetes, but then they'll go into it without properly training themselves and educating themselves on best practices on how to go about using Kubernetes, right? And so let's talk about kind of the initial problems that Kubernetes can solve, right? So the first thing that comes to mind.
Let me ask, Andrew, is Kubernetes your only choice if you're looking for a container orchestration platform?
No, absolutely not. There's a ton out there. I think in AWS land, the two initial ones that I think of are things like ECS, EKS, and then being able to run your container workloads serverless using Fargate. Those are the three typical container orchestration platforms and services that you can see from AWS.
You can run your containers in Elastic Beanstalk too. I wouldn't recommend it, but you can.
Yeah, I would not. I have definitely tried it. It was not. It was not a fun experience. Yeah. So I think Kubernetes would know, right? Let's talk about kind of Kubernetes itself and the problems that it solves, right? So first and foremost, right? With Kubernetes, you can run your containerized applications at any scale without any downtime, right? And so this is super prominent in your production applications where you cannot afford to have any downtime because at the end of the day, it's going to affect your end users, right? So that's first and foremost, right? Is you can scale your applications with zero downtime. The second thing that I initially think of is that it allows you the ability for self-healing containerized applications, which makes them resilient to unexpected failures, right? And so again, like when you're in a production environment, this is not something that you won't have to deal with. The third thing that kind of complements really well is that Kubernetes also allows you to auto-scale your containerized applications per workload, which is huge because one of the benefits of Kubernetes is you can have multiple workloads within the same platform. And so you want to make sure that, if this is the case, that you are utilizing all of your cloud resources as optimal as possible, right? And then I think one of the other things that people typically forget is Kubernetes really simplifies the process of deployment operations, right? And, one of the things that, Daniel and Sebastian will talk about today is, what is GitOps and kind of how does that play into Kubernetes workloads in today's industry, right? But, when I think of kind of Kubernetes and the problems that it solves, it comes down to really six main things. Service discovery and load balancing, right? Horizontal scaling and how do we create a self-healing environment where our applications can heal themselves. When it comes to the deployment of your applications, it gives you the ability for automated rollouts and rollbacks. And then the last two things I initially think of are things like secrets configuration management and then storage orchestration, right? And so when you take all of these things and you kind of think about this at a high level, what you're essentially doing is you're creating a layer of abstraction on top of your infrastructure so that your application developers and your dev teams can deploy applications with all these added benefits, right? And so, as Kubernetes started to be more popular, as some of you may know, we launched EKS back on June 5th of 2018 because what we saw was that customers were constantly asking, like, how do we create an easier way to manage Kubernetes on AWS? Because if folks are familiar with doing Kubernetes the hard way by Kelsey Hightower, that process is definitely a grind, right? Having to spin up multiple VMs, installing all the individual parts, having to manage your control plane, it's the admin overhead is just very high, and it's not something that people typically want to deal with. And so we came out and said, hey, let's go ahead and create a managed Kubernetes service where you don't have to deal with the control plane, and we want to give you the ability to just focus on the application itself. And really just be able to give folks that level of granularity when they're dealing with their worker nodes. So basically, we'll take care of the master node, the master plan, and then as customers, you guys take care of the things that actually matter to you, right? And so that's the big reason why we launched EKS. And so if you even take a step further back, right, when we launched ECS, right, is the question then became, when we talk about the shared responsibility model, customers were constantly asking, how do we push more of the responsibility in AWS so that we can focus on things that matter to us, right? And so this kind of plays into EKS. And from my understanding, when we were launching EKS, that was one of the things that we want to focus on is taking more of that responsibility so that folks that are investing into our container services can focus on things that matter.
Yeah,
and that's kind of what you'll get at EKS.
I wanted to jump in there real quick, Andrew. I think some of the motivation there is it's really difficult to run and scale your own EKS or your own Kubernetes cluster, especially the control plane side, which is exactly what EKS actually, which we'll probably talk a little bit as Sebastian and Daniel go through various aspects of running Kubernetes. That the control plane is this etcd portion and a kube proxy and a DNS service and all these different things that make up the actual infrastructure that runs the cluster itself before you even get to deploy a container out onto Kubernetes. And that stuff is really hard, like etcd specifically, a distributed database, right, that has to run across all kinds of different pieces of compute. That's really hard to do on your own. So that's where EKS steps in and takes that, scaling that control plane side of Kubernetes away from you.
Right. And so to talk about kind of problems that what a managed Kubernetes service will kind of solve for you or something like EKS is that it's kind of what AM just talked about, right? Is it removes any operational complexity of managing clusters. And then EKS manages the scaling coordination of the control planes within your infrastructure, which eliminates any need for customers to have to manage the master nodes themselves, right? Which is a huge benefit for anyone that's investing into a managed Kubernetes service. And so then you run into things like service meshes, right? How do we then provide application level networking to make it easier for all of our services to communicate with each other, right? And then you also have things like being able to run an EKS cluster serverless with things like Fargate, right? Which I think is a huge benefit for folks that don't want to.
Right?
Yeah. We actually launched Fargate of December last year at reInvent, and it was a huge event calling because folks that want to focus on a managed Kubernetes service also want the option to be able to manage these things in a serverless fashion. So we want to give that level of granularity to our customers too by launching something like Fargate. And so for folks that are looking for other things to help kind of make a smoother experience for managing their Kubernetes clusters on AWS, Weaveworks kind of does that for you. And so I'm going to go ahead and hand it over to Daniel and Sebastian to talk about kind of how Weaveworks can help to create a better experience for using EKS for your Kubernetes workloads.
Thank you very much. And so just to, there was a question out there in chat to identify folks. Yeah. So I think right below me, we have Sebastian, who's on the Weaveworks team. I'm also on the Weaveworks team. I think, let's see if I can get my finger correct. Over there, Andrew is on the, wrong way. So over there, Andrew is on the Amazon side. And down in the corner, AM is also on the Amazon side too. So just to kind of provide a little background, and maybe Seb, you can jump forward a little bit. Weaveworks has been around for about 6 years, and we are big proponents of open source software. Seb, can you jump to the next page there?
Sure.
And so we're big proponents of open source software. You may probably have seen some of our projects out there, which I'll talk about in a sec. But basically, Alexis, who founded Weaveworks along with Mateus, who's on our board, previously created RabbitMQ, and before that have been in technology for a long, long time. We have a lot of customers that you would have do know about, but one of the biggest partners that we have is AWS, and AWS is actually an investor in Weaveworks as well. Part of what drove that investment, and do you want to jump down, Seb, to the next slide, is that we actually created EKS Cuddle, because as Andrew mentioned, back when EKS launched in 2018 when it went GA, it offered some terrific functionality, but it was pretty, let's say, challenging to get up and running, especially your first cluster. So we saw that. We were in the process of moving our SaaS offering, which is called WeaveCloud, over to run on AWS and EKS. And so we actually built a tool called EKS Cuddle to make it more straightforward to manage and spin up EKS clusters, and we continue to maintain that. In addition to EKS Cuddle, we created quite a few other open source projects that have thousands of stars on GitHub, or in the case of Scope, billions of downloads. We created a lot of these tools to help us operate our SaaS offering, Weave Cloud. So Weave Scope is great for visualizing clusters. Cortex is a multi-tenant Prometheus open source offering and also part of the CNCF. And most recently, we created something called Flux, which we call the GitOps operator, which we'll be talking about today. So GitOps is something that is, we think, an iteration and an improvement on some core DevOps principles, and we'll be talking about that next. So we continue to be big contributors to open source. We're usually kind of top 11 or 12 in terms of CNCF contributors on a monthly basis. And so we're passionate about that, continue to do that. And I do want to give a shout out. We're having a 2-day conference, a virtual conference this week called GitOps Days, Wednesday and Thursday. If you want to attend, you can sign up on the Weaveworks website. And what I'd like to do is pass the mic over to Seb now, who can give a little more information about what GitOps is, and then go through a little bit of a demo. Please ask questions in the chat.
I was gonna say, Andrew said before the stream started that he was surprised that we were just gonna do 2 hours for Weaveworks, and I think that slide you just had up proves like what he was saying. You all have so many things. It's amazing.
There are a lot of projects. Well, and as I mentioned, a lot of it comes from operating a SaaS platform with hundreds of customers, thousands of concurrent logins on top of Kubernetes, and a lot of skin knees, a lot of lessons learned over the past 5 years. So those things make a big difference.
Well, I just want to call something out too, is, for folks that are learning Kubernetes and are studying for their CKA or CKAD, the one CNI plugin that any course will tell you to learn is the Weave CNI. And so it just shows that you guys are doing great work. And again, like me and AM are super excited to have you guys on the show because, you guys are definitely paving the way for open source tools to make your Kubernetes life easier. Because without Weave and things like EKS Cuddle, like I can only imagine how difficult it would be to deploy a cluster.
Well, thank you. The Weave CNI, just another note on that has official EKS support. So the EKS team has gone through and officially blessed it as one of the few CNIs that work really well on top of EKS. So hey, there's that too.
The few and the proud. That's right.
There you go.
Cool, Sebastian. You want to kick us off with GitOps now?
Sure. I don't think we could talk about WeaveNet without mentioning the open source development team, Brian Borum and some of our developers back in London, and EKS Cuddle deserves a shout out to Ilya, who's one of the Dibichenko, one of the primary developers on the project, who scratched his own itch at the beginning, and then we made it a generally available tool. Because at the beginning, we would do our own hosted services, and we would have the problem of deploying our own applications and maintaining our own code and keeping everything up to date and keeping track of what changed when. And GitOps is the operational model that Weaveworks came up with to solve that problem. The term GitOps was coined by our CEO, Alexis, way back in the day, 5 years at this point, and right around the same time that Kubernetes started, and so that the confluence sort of helped propel both projects higher than they would have gone individually. GitOps, in its basic sense, is about taking declarative infrastructure and turning it into a standard workflow. Basically, I'm not a fan of reading the slides. You can probably read the slides faster than I can talk, but you have a Git repo that contains your declarative infrastructure or anything really that you can describe declaratively, and tracks it using the Git Merkle tree to keep track of all of the different versions of who changed what when. And you would then have a target in your Git repo, usually expressed as a branch or a reference, that points at the commit, the head of the commit that you want to make sure is always the version that's running in any given environment. And GitOps goes even beyond Kubernetes. It's basically an automated process that you can apply in all kinds of different environments. The idea there is that you have a system that you can describe in declarative language, whether that be YAML files as you have Kubernetes, or whether you have Terraform templates or JK templates, or anything that you can set up as a system of declarative statements. And then you have a versioning system, which that's where Git comes into the picture. Me being a big Git fanboy, I always think that a Git is the versioning system everybody should use, but you can use other versioning systems. But why would you? Because Git is awesome. And then you have the state. You have something that describes that thing, that point, which is usually the head branches, the state of an application. Then in your environment, you have an agent. You have what we call a Git controller, a GitOps controller. And the controller will go and get that set of declarative infrastructure by monitoring the repo, or by getting webhooks, getting events from the repo anytime that changes, and it will apply them to the environment. Not only that, the second main goal, the second main function of the GitOps controller is to monitor the environment to make sure that what's actually running is what should be running. It compares the state that you want, the desired state, against the actual state. So the software agent, the Git controller that's mentioned there in step number 4, ensures correctness and alerts you anytime there's a difference. So basically it's diffing from the developer standpoint. It's diffing the current state against the desired state. And anytime it diverges, it can overwrite, just basically take out the change, or it can alert and set off everybody's pagers and wake everybody up at 3 o'clock in the morning, which in this case is what you want. But for example, we run a GitOps controller to track our Git repositories. Being the company that we are, we have so many Git repositories, they're very difficult to keep track of for any one person. So we have declaration files that describe the Git repositories that we want. And then anytime somebody wants to add a new repository or delete an old repository or something like that in one of our main organization spaces, they go through the Terraform steps, they get their change approved, that gets checked into Git, and our controller then applies that to our GitHub organization so that those Git repositories always match the set of described repositories. If anybody adds a new one or deletes an old one or makes a change that they weren't supposed to, or a user gets approved to have access, or any kind of event in that space that didn't go through the approval process, we get alerts in our Slack channel. Sometimes we get paged, and then we go and we figure out what happened. And in that case, we don't just automatically roll them back, because that can be a little bit disruptive. So what we do is we go and we look, and we usually end up chasing the person down who made a manual change and make them go back and follow the right process. That's one example of a GitOps controller. And in Kubernetes, the one that we built and released is called Flux, and that controls your Kubernetes cluster in the same way. You make your changes into your repo, and then you apply that. Flux applies those changes from the Git repo to the cluster.
So I just wanted to pause you there real quick, Sebastian, and just
Sure.
take a step back a little bit. I think maybe most people in chat are probably familiar with CI/CD in general. You've got a version control system for your code, right? And I think most people have experienced CI/CD workflow with code, right? Just our application software that we're building. We version it in something like Git, and then trigger various build stages and a release pipeline down the line with every commit to a certain branch or whatever, right? In our code workflow. But what you're actually talking about too, I think that's important to call out, is this isn't just code that we're tracking here. This is like actual pieces of infrastructure that then your code runs on.
Yeah, I mean, I guess that depends on your definition of code. So it's not necessarily application code.
Right.
But if you think of code as just a series of statements that describes the thing you want, either behavior of an application or the state of an environment, then that code can express a thing. Declarative infrastructure, from my perspective, is basically code. It's just code that's written in a language designed for systems operators and systems analysts to understand and express, right? Because Java isn't necessarily well designed to describe a state of a bunch of servers and a networking layer and everything that goes along with the deployment environment. That's why they came up with declarative languages like Terraform and YAML and even JSON to some extent. I've even seen an example of that same thing that used XML and DTDs. I wouldn't recommend it to anybody, but it does work. And basically, it's just a series of statements that say, I want a networking layer, I want these ingresses, I want these control ports, and I want a firewall set up with these rules, and I want these servers. And those servers are all connected to the firewall. And basically, you describe everything that you want in whatever language works for you. In this case, because we're talking about Kubernetes, you're talking about a series of services and ingresses and pods that describe an application deployment. But the same thing can be used to describe any set of things. And as long as you can declare it in some way, then you can build an operator that reads it and applies it to the environment that you want to see that happen in.
Cool.
I think one of the things that we missed from the beginning of the conversation is why are we doing this in the first place, right? And I'm glad that you brought up the continuous integration because, again, that's going to be on the next slide. But as an application developer for a long time, one of the things that we would run into before containers became widespread was the whole runs on my system problem, right? You would build an application while you were working on it in your development environment, and usually that would be on your own machine, your own laptop, or your own team's special development server, and it would work fine there. And then when you actually went to deploy it on release night, everything would burst into flames and fall over, and you would have to roll back, and you'd go back for another month. It might be another month before you have a release window or maintenance window, and you have to go figure out what happened. I worked even on teams years ago that would build an application. You work on the application as a developer in your development environment, your IDE on your system. And then when it came time to build a release candidate, it would be built on somebody else's system. In some cases, that wasn't even a developer because nobody wants to be the release master. It's kind of a thankless job. You can only ever do things wrong when you're the release master. And you can only be blamed for somebody's code not working because your environment is different from theirs. And the person who would build these applications at times was a project manager who had almost no development knowledge. All they knew how to do was run a couple of commands that built the project. And if something went wrong, they would just have to call the development team in to figure out what was happening. Containers solve that problem because they don't just describe the application. Your container is a description. It's like a declarative language that describes everything that application depends upon. I expect this application to be deployed on Linux, Ubuntu 8, with this series of dependencies and this series of special configuration files. And all of that is in the container definition. And when you build an application now, at the end of your CI pipeline, right, you get not just a jar file or a WAR file as you go with the Java application, or an executable if you're working with a compiled language, but you get a container definition that includes that application, but also all of its dependencies. So you never have the runs on my system problem, right? You get everything in one package, and then that package travels together through each step in the deployment process. Every time you have a development release candidate, it goes to your development deployment system as the package. And then when it gets approved to go to UAT, it goes there as the package and so on, so that every step along the way, you know exactly what it's traveling with. And if you need to change the dependency, you change it in the image, and then that dependency change travels with the image. So it all comes together, and you don't have to have, some systems operator who doesn't want to be awake at 11 o'clock at night on a Friday logged in with you on release night, making sure, and then like manually running through a list of dependency changes, running yum, 10 times because they need to, change the entire application stack under your WAR file.
Yeah, I think
so.
What's
That was a big problem,
is,
and this is what's solved by containers. But the basic desire there is I want my code to run, right? And developers, they don't necessarily even care about everything else that goes along with it. They just want the code to run, right? They care about the code, they care about application features, and this, just using containerized application development, lets them think about that code and the application's features 90% of the time, and only have to think about the dependencies and the deployment 10% of the time when they really need to change something. As you were saying.
Yeah, I was just going to say, it's kind of interesting to look at this in a sense that, the Docker file is like the manifest for the actual environment where your app code runs, and then like these YAML manifests that you declare out for your Kubernetes environment are the dependencies that the application itself then needs. So, I mean, you're doing it like all the way up to the level of deployment beyond the application code itself and the environment it needs to run in. It's also the environment that sits around it that you can also declare with some of these, you mentioned Terraform, there's CloudFormation, there's these Kubernetes manifests and YAML.
Illumi now, yeah.
Yeah, it's kind of interesting. It's declarative languages all the way down, right?
That's right. There are so many turtles.
Yeah, exactly.
Eventually you hit dirt, I think, in this model, but Yertle is down there at the bottom. He's the actual physical server hardware that exists somewhere. The main advantage to this is the developers don't have to worry about Yertle. They only have to worry about the turtles and maybe 3-4 layers below them. And then once you start getting down into servers and firewalls and what services are visible, that's where your operations guys come more to the fore. This gives them the ability to describe a package in such a way that that description travels with the application, and then they can deploy it anytime they do. On release night, they know exactly what needs to be done, and it's described so that they hit a button, and then those 100 changes can be just made, and they don't have to be there for 3 hours changing firewall rules. 3 hours is an underestimate sometimes. But in some places that I've worked, you would only get to change firewall rules once a month. If you wanted to deploy an application, even in your development environment, and you needed one service to talk to another service, and they were on other sides of a firewall, you would have to wait a month before you could even try it in your development environment, like maybe not on your machine, but on in the development servers. And then that was a huge impediment to development. And, it just made you less likely to want to try something innovative because the pain level was so high to try to change something that you just avoided it at all costs. I've even seen people basically write a copy of the same service so that they didn't have to go across the firewall to get at the service that they needed to get data from, just so that they had non-production data that they could read from a mock service. And it was a big problem, and that problem is much more solvable now because you have a process of pre-review, you have a process of it's like a shared standard language that you use to describe the deployment environment that you need. In this case, that's the Kubernetes YAML, but then it also can go as far as your underlying infrastructure. So continuous integration pipelines are all about producing that package, right? They're about producing the image that describes your application and all of its dependencies, right? At the end of a continuous integration pipeline, you get a container. And containers used to be Docker. Docker was the thing that you used to create containers. Now that's changing, and you have many more ways to create containers than we used to. But that container is the end result of your CI pipeline. You've built your code, you've run your linters, you've run your unit tests, you've run your integration tests. You've stood up like a fake server somewhere and you've run some functional tests. And this is ideally because, in the real world, a lot of times that may not be the case, but still you've got, at the end of it, you've got something you're pretty sure is going to work. And it's there described as a package of an application and all of its dependencies. So that would be your image. That's the build step there. Step number one is at your IDE. This is like a developer's life here in this little circle, right? This is your job. You work in your IDE, you check in your change gets built, right? You check it into Git, Jenkins picks up that your branch has changed or picks up that you have a new feature branch, and it builds that feature branch. It runs your static code analysis. It runs your unit tests. You fail 5 unit tests, you start over at your IDE, and eventually you go back and you produce a build image, and that's the end of the build stage, right? That build, then you know that build is good and you want to deploy it. So what you do is you tell it, hey, my image is ready. I want to try it. And so you need to tell some system, hey, I've got a development branch and I want to actually run the image that we just produced. How do I do that? And most of the time as a developer, you don't really care. That this is not a concern that's at the front of your mind. You just want to have something to poke at so you know whether your feature is there or not, whether it works the way you think it should or not. So you're going through this cycle, right? Because what you want to do is you want to work on code and you want to just hand it off to the build system and let that build system work. And then when everything's approved, you check your code into Git and then you run the test and then off you go. You're basically, this is where developers live in this realm. But then at the end of that realm, when you want actually to run something, they've got to take that image and put it someplace. Most of the time as a developer, you don't care that much about where they put it. You just want to be able to hit it. You want to be able to poke at your service. You want to be able to run your application. You want to be able to see it in your browser to make sure that it actually works, aside from just on your system. So what you want is for some agent somewhere to say, okay, thanks for the image. I'm going to put it over here, and here's an address, and you go to this address, and it will work, or not. Good luck, buddy. So that's the next step, right? You've got deploy. Now, those are really two different things. Deploy isn't part of the first circle, right? You don't have to know anything about that. As a developer, you generally just check in your code, and everything else is kind of overhead. Right, just like the overhead of starting up Kubernetes when all you really want is to be able to deploy applications. From a developer standpoint, that deploy step is overhead. So they would rather not have to think about it. If you think about those two things as separate concerns, then it starts to make more sense to not make them part of the same pipeline. Continuous integration and continuous deployment are two really separate things. And if you start to separate them, you start to think, well, how can we do this in such a way that continuous deployment doesn't depend on continuous integration, or vice versa, right? If at the end of your Jenkins pipeline you run a deployment job that then reaches out to possibly 5 or 6 servers in different environments and actually moves your WAR file over there and sets everything up, then you've made deployment part of your CI pipeline. When really, most of the time the developers don't need to know. Right? They just want to get a window. So if you separate those concerns out, you can do things like have your CI pipeline produce an image and then have 5 or 6 environments say, oh, hey, there's a new image. And then pull the image to themselves instead of have your CI pipeline push it. Right? So the difference there is a push model versus a pull model. And that's where we get into this. This is really 2 circles. You've got continuous integration on one side, and you've got continuous delivery on the other, right? And then the idea is to make it immutable in between them. You want to separate those concerns so that continuous integration doesn't have to know that much about where things go, and then continuous deployment doesn't have to know that much about how things got built. They just want to say, I have a new image. I'll just take it and I'll deploy it the way I know how. That's what happens in the continuous deployment pipeline. Whereas on the other side, it said, hey, I produced a new image. Now it's your problem, buddy. Right? Hands off to your agent. And what's happening on that right side, on the deployment side, is an agent is a GitOps agent or a GitOps controller is running in the environment that you want to deploy things to, and it says, great, I have an event, right? I have a new image, or somebody changed one of the configurations that describes me, and I'm just going to take it and I'm going to apply it to my environment, and then if everything looks good, we're going to keep going. So the intermediation point between these two circles is your Git server, because the main good thing there is most application development environments, most application teams have a Git server. Even if it's not Git, they've got a versioning server. But hopefully at this point these days, it's almost always Git. I'm just putting the plug in there. But in that middle, that's the point where everybody can see the results. You've got your Git server that describes the thing that's got to be built. And you've got an image, also an image repository, but the configurations in a Git repository describe what then needs to be done, what changes need to be applied, what version of the image you want to run, in what environment. That's all described in declarative infrastructure and the declarative language. So Git becomes your single source of truth, right? The advantage there is everybody has a Git repository at this point, and it's a tool that everybody knows. Your developers know how to use Git. Your systems operators know how to use Git, because basically they've been keeping the thing alive for years. And they don't have to reinvent the wheel to have an additional agent that figures out what goes where. You describe it in Git, everybody knows what the approval process is, everybody knows how to do a pull release, pull request, everybody knows how to commit changes, and that's the interface that you can use as an interface that you know. And there we go. I had my cursor in another window. So Weaveworks. Weaveworks is the GitOps company. We basically, put our flag in the ground on GitOps. By the way, Weaveworks is not WeWork. It's Weaveworks, like a basket. We do have a WeWork office in New York, which is the Weaveworks New York WeWork. And so it's fun to work there because it's its own tongue twister. But what we're doing is we're taking the landscape of things that are available, and we're making them, we're making GitOps work in all of them, right? We've got open source projects that support GitOps and support declarative infrastructure and support this deployment model. We've got services that we offer, CREs, which is basically making your Kubernetes deployment reliable. We do consulting. We'll help build proof of concepts. We train people in GitOps and Kubernetes, and we'll help you get your deployment environment up and running up to speed and available to your developers much more quickly than you might if you were starting on your own. And then in addition to that, we have our own curated Kubernetes platform. That's where WKP comes into play. If you've got hundreds of clusters, if you're deploying Kubernetes over and over, if you've got a globally distributed organization and you want all of your development teams in Karachi and Bangalore and Taiwan and San Francisco and New York and London and Cairo, you want them all to have reliable environments that they can at least mostly depend on, so that they know that they're basically running in the same environment that the team in London is running in, is also running in Taiwan. They basically can use our platform so that it reduces the management overhead. It allows you to control your fleet of clusters, not just one, and describe how you want your applications deployed in a way that can be reproduced across all of them. Repeatability, flexibility, and observability. Observability is more about your metrics and your systems that you use to track them, but that's also an important aspect of Kubernetes. That's why log files exist. That's why Splunk is, and Splunk and Fluentd and Datadog and Loggly are so great, and that people love to use them because they combine all of the data that you're getting from all these different environments, all that observability data, and make it digestible and make it searchable. And you can amalgamate them into graphs and charts and then produce a really nice report for your boss at the end of the month. So that's where Weaveworks is. We love GitOps. I should actually have a t-shirt that says Weaveworks loves GitOps, but my idea was shot down in committee. I'm still sad about that. So this is a little bit about the Weaveworks Kubernetes platform. This is what we bring to the table with our product. Everything, you see the Kubernetes layer is one big block going across the screen there near the bottom. Hopefully you guys on mobile can see it too. It says Kubernetes, the letters might be really little, but that's where that little blue steering wheel is. Everything below that layer and everything below that layer is your infrastructure. That's your your basic building blocks, right? You've got your networking, you've got all your disks, you've got everything that you use to stand up virtual machines. Most of the time, you've got some of that figured out, or you've got even maybe most of it figured out. You're using AWS to build a VPC, and you're using that product? I think, Andrew, that's like, if you're in the medical industry and you need a private network, a VPN basically on AWS, all that stuff is part of the solution that you have, because that's an expression of your business. That's your machines. That's how much you want to put together and make available to everyone. Then on top of that, you have Kubernetes, which is basically providing a mediation layer between your applications and all that infrastructure that lives below them. And then above that, that's where WKP kind of comes into the picture mostly. You've got, how do you manage your clusters? How do you manage 1,000 clusters? How do you figure out what components get deployed onto each cluster? How do you configure your observability, your logging, your alerting, your metrics and your charts and graphs and all those screens that go in your data centers with the red buttons and the blue buttons, that people are supposed to be paying attention to when they're actually watching cricket matches. That's basically all of the infrastructure, all of the supporting systems. And then the next layer up, where all the yellow boxes are, that's where your developers come into play. That's where your developers are starting to care about these things. And then they're going to notice when things start to go wrong, like where do their images go? Container control, that's one thing. Release management, when do images get deployed? Visualization, hey, how do we figure out whether we're getting half of our traffic is getting dropped or half of our requests are being rejected? Alerting also is part of that. Monitoring metrics, auditing, dashboards, and rules, deployment policy, like when should this happen, who needs to approve it, all that stuff. That's all part of the developer's world. And then on top of that, in the gray boxes, that's where the rubber actually meets the road. That's where you have your applications. Your business people are going to be only going to care about that top layer. They want to flick the switch and see the light goes on. That's the workload. Everything below that is the wiring really behind the walls. And your developers care about the stuff that's in yellow. Your systems people care about the stuff that's in blue. And until recently, until you got into these systems, until you got set up with Kubernetes, until you got more into declarative infrastructure, that was a pretty big divide. That wall was high, right? I don't know, you probably had this experience, Andrew, where you build an application and you want to make a change and you say, oh, I need to make this change to the environment. Hey, somebody stand me a server, and you fill out a ticket, right?
Every time, 100%.
And then every ticket has to be properly aged before it can be ever executed, right? You need at least a few months for the ticket to become stinky and covered in mold before your application actually, before your request actually gets processed, before your firewall holes get made, before your virtual servers get created, and so on. And that in recent years, and especially now that we've got this, containers and container orchestration, that wall has started to come down. And the time between the time a developer makes a change and wants to deploy it and wants to see a new system has gone from the month-long wait to the hopefully less than a day-long wait, but sometimes it's a couple of days, depending on your approval process. But you don't have to wait for somebody to get around to it anymore. This is all becomes part of the system that you put together, and that sort of makes the divide less stark. It reduces the workloads of the people who are on it, so they can concentrate on innovating and concentrate on doing their actual projects and don't do as many repetitive tasks. And it makes everybody happier. That's kind of why I got into this whole space. I started getting much more into cloud computing because I wanted developers to be happier. I wanted to enjoy my job. Being a coder is fun, right? And all the other stuff was not fun. So I want to concentrate more on the coding, and I decided, hey, how do I solve this problem? And I ran across, cloud computing and said, that's got to be the answer. And then as I got further into it and got into, Galactic Fog, that's sort of how I followed my joy. So Weaveworks platform. Weaveworks platform increases that joy and makes that problem smaller by giving you a curated platform that is also modular, that you can swap out components that you want to change, but you keep the best practices for everything else to help you get going faster than you otherwise might, and to provide a set of practices that you can then follow or that you can then implement to get going faster and to keep your systems up longer and more often. That's the basis of this. You can see it's the same diagram, but you've got a different list here on the left, which is always fun to read. I'm not going to go into it too much, but you've basically got your description of your infrastructure, and then part of our system, if you engage us for this, is about how do you set that up and like how do you implement it, and that's something that we can help with. But then lots of people already have that problem solved. Well, then on top of that, what happens next, right? So upstream Kubernetes and GitOps, how do you manage lots and lots of clusters, and how do you make reproducible, repeatable deployments? That's the next layer up. That's where WKP starts to come into play, and GitOps and some of the repeatable practices. And then on top of that, you have day 3 concerns, such as how do we keep track of all this? How do we monitor it? How do we package it? How do we make sure that we're describing applications in an understandable way? And then how do we keep it flexible so that it doesn't become more abundant and you don't end up just slowly becoming, going back into the same problem. So by providing a set of curated options that we put forward as best practices, and by the way, most of the components that are curated as part of this package are open source. So you could put them all together yourself, but we can make it easier by packaging. And here's where we, I really don't even get this picture. It's like these blue blocks and these gray blocks. But basically, this is where we fit together, right? You've got your applications, you've got your add-ons, you've got all the core stuff, Kubernetes and CNCF core projects, and then supporting all of that, you have your providers, one of them being Amazon, and we won't mention the others today. You're welcome. So the difference there, what we deliver, what we can bring to the table, generally are the things that are above the line, right? Our release engineers, reliability engineers, and platforms teams can help you build the platforms that go on top of the infrastructure. And then your teams, your operators, basically run them and build everything below them so that you can offer things to your development teams on top of your infrastructure and the clusters.
Hey, Sebastian, we actually had a question from chat. Are there going to be demos?
There are. Believe me, I'm trying to get to them as quickly as I can.
Okay.
In fact,
I think they're getting restless.
In fact, I like this slide because it's very colorful. This is a bunch of stuff, right? These are all the parts of that system that sort of fit together and how they, all, become a mosaic and blah, blah, blah. But it's just a pretty slide. So, I'm always reluctant to just drop it. Basically, this is more about how your clusters fit together when you install a cluster, when you configure a cluster, the difference there between day 1 concerns and day 3 concerns. Multi-tenancy is a big thing. Basically, people want to sometimes run an individual cluster for an individual development team, or they want to run one big cluster and have maybe 5 or 6 or 10 or 20 development teams running on it. how often do you update the underlying systems, how often do you upgrade Kubernetes, and all of that stuff. That's all part of the same service. So Kubernetes offers a platform for developers and operators. Again, I think we talked about this a little bit more, that wall between developers and operators. Developers are working on code, they're committing their code, and they're submitting it to a build system. The CI system builds their applications, and it pushes those applications to a registry. It used to be primarily Docker registry. Now it's becoming all kinds of different ways of serving your application images. Operators, on the other hand, they're interested in the infrastructure below it. So they're watching a different repository that's describing what's going on in the cluster. All the underlying pieces of the cluster, like, is it running Prometheus? How is Prometheus feeding its metrics back to a metric server? How are the logs getting from the servers back to the aggregator? And all of that stuff, that gets described in declarative infrastructure. And then the deploy agent here in the middle pulls those configurations from the operator's repo. And the operator's repo has a tag, usually, that says, what image do we want to run as part of this deployment? The deploy agent goes and gets that image, combines them together, and then deploys them to the cluster. In this case, you've got two Devon stage namespaces, and so the deploy agent will deploy your application to whichever namespace is in your declaration. This is all about packaging. I think if you're a developer, you understand this. So this is kind of more for point-to-haired bosses. But basically, you've got your packages, you've got your images that go to a registry, and how they're deployed is described in YAML files. That's your config map and your cluster declaration. A cluster declaration is just another YAML file that describes what kind of cluster you want. If you want your clusters to spin off automatically, that can also be a template. So say you're checking in changes to a feature branch and you want to spin up an EKS cluster automatically to test your feature branch, run a bunch of integration tests against it and take it down. That cluster that you want to spin up automatically is described in that YAML file, and you can have a template that just generates them whenever a feature branch is checked in, for example. Cluster configuration. So this is basically, you get the idea from the slide before. You have your set of machines that are VMs. So like if you have a bare metal installation or you're running VMware in your data center and you have a set of machines that you want to be able to set clusters up on. So you may have a machines YAML file that describes the VMs that you want to be able to run the cluster on. Again, that can be a template and pick a list of VMs out of an available data source. And then say you want 3 VMs, it can basically either spin them up for you by feeding that back into your infrastructure controller or by picking from a list of available ones and then putting them into the YAML and checking that into Git. Once it gets checked into Git, again, the controller picks it up and applies it to the cluster. Whew. Sorry to run out of breath. Does anybody have any questions at this point? Because this is just text. You can read it faster than I can speak, even though I speak fast. Basically, your Git repository has your YAML files that describes your cluster, describes your nodes, describes the workloads that you want deployed, all of them in YAML files or in JSON files sometimes. And in addition to that, says how are you going to authenticate users and so on. So you can either have a command line tool, in that case it could be kubectl, it could be fluxctl, that kicks off those events, or you can have them kick off automatically. And then cluster nodes can be anything. It says Red Hat, Linux, or Ubuntu LTS, but that's basically for WKP. But I've seen examples of people doing this on, Raspberry Pi machines and things. So the maintenance of a cluster, basically, this is the same idea represented again. So many diagrams. Once you've seen one diagram, you've seen them all. This is where machine configuration comes from. Again, you're picking them out of a Git repository. You're generating them from templates using JK and Flux. So say you're using manifest generation. That's one of the things that it does. It'll apply those generated templates to your cluster. It stores them in etcd so that you know what is actually supposed to be running. And then the WKP controller can then create a cluster for you and get all of your configurations and apply it. And then you end up with the end result, which is Kubernetes with all of your machines and all of your applications on it. So this is kind of combining the two previous slides.
So,
Transformation.
Sebastian,
Yes.
So,
Yeah,
so quick question for you. So, with the demo that you have provided for us today, how much of this plays into what you're going to show us today? Just out of curiosity.
Oh yeah. So I can show you today basically what all these files look like. This is how they fit together. But then when you actually look at them, you can see, first of all, how this is expressed, and then the potential for automating things and templating things to create a series of predefined, we call them models, models and profiles. The models would be what you're storing previously in the Git repository to describe the templates of a cluster, and then the controller would the WKP in this case would pull them from the Git repository, apply the changes, apply the cluster name and the machine names that are picked from the list, and use them to spin up a cluster. In addition to that, apply all of the predefined application workloads. So you want Prometheus, you want Cortex, you want Flux, you want the Helm operator. All of these things are part of the profile that describes the underlying stuff that's supporting your application deployments in your cluster. But I have a slightly more visual example of that before. This is what that machine YAML looks like. It's not all that exciting. You've got a name, you've got what kind of type it is, you've got the IP addresses and the ports that are exposed and how to talk to it. This is a cluster definition. So this would be a cluster definition for an on-premise cluster. So not an EKS cluster, but say you've got real machines. So you're defining a cluster here, and you're telling it, use the 1096 and 192.1680 subnets for your local network routing. And this set of machines, and this is the version of Kubernetes I want to run, and this is the container engine that I want to run, describing your bare metal cluster.
I think it might be worthwhile to show some of this, Seb.
Yeah, I'm trying to go through. This would be for EKS. It's the same idea. You're describing, if you're familiar with EKS clusters, you can see you're describing your node groups, you're describing your management layer, and your policies, and all that stuff. So all of the details of maintaining and spinning up clusters, including upgrading them, including how many nodes there are, including the version, including all of the, how many node groups there are, that's all expressed in YAML. And all those things are checked into Git, and then they can all be managed. So that when you change something and it doesn't work, you can roll it back. When somebody changes something in the real environment and they didn't get any approvals, immediately it gets rolled back automatically. You have that ability to check. You can also see that run linters on things when they get checked into Git to make sure that somebody didn't forget a comma at the end or forget to quote a string in their YAML, which I do all the time. But the linters can catch that as soon as it's checked into Git before anybody actually tries to apply it. You can also sign your commits, which I do habitually, so that everything can be auditable. You can track it back to the right person. You know exactly who changed what, when, and why. Here we're getting into the attractive young people looking wistfully at a screen that you can't see. So I'm going to use this as an opportunity to switch and show you some interesting stuff. You guys can all see this, yeah? This is our installation of WKP that we have as examples. It's a little messy because a lot of the CREs and the application use it. So my whole team uses it to demo things. And while we're demoing things, we throw things on there. But the ones that I would like to show you now are the ones here at the bottom. This is your management install of WKP. And you'll notice that this is running on an EKS cluster. You can see the load balancer name up there. But it's actually got descriptions of several clusters that it manages. This one here seems to be in the process of updating, so I'm not going to click on it much, but I can show you the two ones below. And also, I can show you the parts of the application that you can work with. So what you would do here, if you want to create a new cluster, is click this Create Cluster button, and then tell it what kind of cluster you want. It's got a generic name here. This here is a model. And this model is basically a predefined type of cluster. So you can have say you want to have a monitoring cluster. That's a cluster that runs a big storage layer and is running Prometheus so that other clusters can feed metrics into it, and this is where you go to get your charts and graphs. So that could be one of your models. Here we have Portworx example, which is a storage layer. They'll do disaster recovery. So they'll have a DR cluster, which is storing copies of all of your etcds and of all of your declarations, so that if your cluster goes down or gets blown away, or the dog eats it, you can restore it from the Portworx cluster. Production clusters, that's where you deploy your applications. Machine learning clusters, a specific type of application, and so on. Your providers, there you pick from a list. We won't talk about the others, but EKS is on there, and that's where your cluster will be deployed, and so on. And all these things below it are then dependent on the provider that you pick. So you only pick node groups if you wanted to pick an EKS cluster. I won't actually do that because there's a good chance that I will burst into flames because I forgot to sacrifice a goat to the demo gods before this call, but I do have existing clusters. It also takes a little while for clusters to spin up. It's always fun watching paint dry and watching clusters come up. I'm sort of obsessive about watching my own logs. But let's see the workspaces demo one. If you click into an actual cluster, you can see this is the single cluster view. This is the main page that you use to see what's going on in your cluster. I like to start at the bottom because I think this is kind of cool. These are your nodes here, just expressed as a series of little widgets. So you can just see at a glance for the nodes that are part of this cluster, how loaded are they, how much memory do they have, how many pods are running on each one. And then you can view the individual dashboards, which I won't click into right now because that's as far down as the rabbit hole goes for me right today. Above that, you've got components. Now, the components are not your applications, but they're supporting applications. They're things that are running on your cluster that support the environment. In this case, you can see the ALB Ingress controller is on here. That's the thing that sets up application load balancer rules when you start a new service. And you want the ALB Ingress controller on an EKS cluster because otherwise, how do your services get traffic? DNS, Bootstrap, the Helm operator, that's pulls when you add a Helm release to your cluster, that actually will go and deploy the application using Helm. You get out to repo broker, you can use a couple of different types of repo, GitHub and GitLab primarily, and this sort of intermediates between the two. Grafana, Prometheus, and Scope. Grafana is your charts and graphs. You're familiar with Grafana, I think. This is basically where you define your monitoring part. So I won't get too far into this, but this is the main Grafana dashboard. Now, these are open source components. So if you know Grafana and you have your set of Grafana rules, you have your set of dashboards already defined, which a lot of places do. You just import them here, and then you're off and running. You can make that set of dashboards part of your declarative infrastructure and part of a model, so that when you deploy a specific type of cluster, that set of graphs and charts gets deployed along with it and gets made part of the Grafana installation for that cluster. And I'm going to click that off, and I don't have the monitoring link, but it should be there. The Prometheus, right? You can see this is a standard deployment of Prometheus. It comes with Alert Manager. It comes with all the things that you've done. So if you've deployed Prometheus already on your applications, you can turn that single deployment that you've done, and you may have to have been repeating manually every time you deploy a Kubernetes cluster, you can make it part of the model so that when you spin up a cluster, it deploys Prometheus for you automatically with the predefined set of metrics, with the predefined set of scraping rules, and all the things that normally go along with Prometheus. They're expressed all like a template. Scope. Scope is basically, I don't know if you're familiar with Scope. It's one of the most fun open source projects because it's kind of just fun to look at. I'm going to actually open that up here. Now, Scope describes what's going on in your cluster in real time. So you're visualizing what's happening on your cluster. In this case, I'm looking at just a subset of the pods because I have picked these two namespaces. But what I'm going to do is just make this. So this is everything, all of the pods, all the controllers that are running on your cluster. And you can see how they're interconnected, what's feeding data to what. So for example, the Flux Helm operator is feeding things to the tiller deploy agent. Your Grafana is connecting out to the network to feed graphs, and so on. All these lines basically are network connections, and all of these items are nodes. So if you want to look at the host view, this is the highest level view. This is all of your nodes, and you can drill in on any one of these nodes and see what's running on it, what the metrics are, look at its logs and things like that. So if you've used Scope before, that's the general idea. I can actually click in on one of them, and you can see here on this node, you've got these are your inbound and outbound connections. Obviously, these are all network connections, by the way. So if you've ever wondered, well, what is this thing talking to? You can see this listed in this interface. These are the pods that are running on this node. These are the containers that are running within these pods, and then there's plus 25 more. You can expand this. So you can actually see immediately what's running on a node and what processes are running on a node, almost like you're sitting on the node running top, except it's across the containers that are all running within it. So if you wanted to see the logs for Flux, for example, you could click into the Flux container, and then you'd be able to show, actually, if this is the container, that would be at the pod level, but you'd be able to see that Flux is running there and how much of the processor it's using. And this is extremely useful for when things start to go wrong, because you start at the high level view and you see, okay, nothing's going wrong at the high level view, that's obvious, and so you start to drill in lower from there. So starting at the node, you can go into pods and view the pods. Sometimes it's a little easier if you just filter by namespace, so you want to see what's happening in your alpha namespace. I think it's just got this one Flux agent running right now, but basically you can drill down and filter by any set of rules. Namespaces are easy, but you've also got a search box up there. Here you can see the list of containers that are running and where they're running generally, but you can also click into individual containers and see what's going on with that, individual stats and what they're connected to. And then here, this is like a process table. Now, I like to look at this view as a table. So if you're used to logging into a server and running top on a server, or listing all the processes on a server to see what's going on, to see if anybody's using a suspicious amount of CPU or memory, or if they got a lot of file descriptors open, or something like that. They've got a giant number of threads because there's a thread bug. I can't even remember what that's called. But essentially, you've got you've got multi-processes running, and then it's forgetting to close them. You can see that right away because that would pop up on the threads listing. You can even list it by the number of threads that are running. So if one is running 6,000 threads, you know that right away. I've found this really useful for my own debugging, but this is the kind of day 3 concern that you get into once you started running Kubernetes in production for a while. You want to be able to try to drill down to solve a problem that's happening immediately by starting big and then focusing in as you start to see what the problem is and which direction things go. So that's the table view, and this is the graph view, and we also have a resources view that you can look at, but I won't focus on that too much. Just close the scope window. In addition to that, on your cluster, you may have several teams. So if you're using a multi-tenant model, you may have several teams that are using the same cluster, right? Generally, you express that in kubectl as namespaces and as the series of resources that run within the namespace. What we've done as part of this product is use the multi-tenant model that we have with Flux, so that when you want to have several teams who are sharing access to the same cluster, you have an automatic way to set that up, and you can even make that part of the model. What we've got here is a series of namespaces, so you can see that Team Alpha has their own Team Alpha namespace, Bravo, Charlie, India, and Victor. So that's basically just made-up names, obviously, but each team has their namespace on the cluster, and each team has a repo that the Flux agent running in that namespace, scoped strictly to that namespace, will go and check their changes from. So, and this is just a Git repo. The YAML files, and there's nothing in this one, but the YAML files that you have checked into this repo describe the application that team maintains and nothing else. So you want to shift as much of the responsibility for maintaining their own list of dependencies and their own list of desired services and be able to know what services talk to each other to the application development team. You can give them their own repo that they check in their own changes to, and then you can either have an approval process where your operator team looks at those changes and approves them before they're merged into the master branch, or you can let the team be responsible for themselves in the dev environment, and then you only need to double check them before you promote them to UAT, or any set of policies that you want to have. That team then can control its own development environment so that they don't have to turn around and ask the operations team for every little thing. That's the main advantage of workspaces. And creating a workspace is basically just a matter of defining a namespace and defining a Git repo that it pulls from. Are there any questions at this point? Have anything on chat? What about you guys? I've been going through quite a bit of that application, but basically this is designed to support an operations team that wants to support a bunch of development teams in the DevOps type of space. And this down here is the Git branches that it's pulling from, so you can see immediately that it is pulling from this master branch. That's where it gets all its configurations. And you can even just click into it and go in and see this. In this case, it's a GitHub repo. Everything that lives in this master branch. You've got documentations. You've got your platform UI. This is a set of rules for what Flux is actually going to try to apply. And you can see that in here you've got a bunch of, in this case, it's JavaScript and YAML files that describe the set of application components. So like the components that run on this application are described here in components.js. If you want to define another application that also runs as part of the cluster infrastructure, you can edit components.js and check the change in here automatically. Or if it's the change you want to make is supported through the WKP UI, you can do it there. That would actually apply a change to this Git repository in order for it to be picked up by the Flux agent and applied to the cluster. It doesn't just go and do it automatically. Everything goes through Git so that you have that auditable set of changes and you know exactly who made what change when. I'm going to close this window. Just for giggles, and I know this is lots of fun, we're going to go back to the management cluster and show you what cluster definitions look like. This is that management cluster. So you've got your components and everything described here. Everything that's running on the management cluster. And you've got your Git repository that describes the management cluster's components. But in addition to that, that management cluster includes, or should include, the clusters YAML. So all of the clusters that this management cluster is watching are described here in that cluster's management repo. So if you want to do something weird, which a lot of people do things weird, if you want to do something that's odd and you want to change some configurations that that there's no button for in our UI, for example, you can go here into the YAML file, and if that field is supported there in the YAML file, we have some pass-through things, like you can define a series of kubelet start parameters, for example. You can see in that cluster YAML, this is probably might be an older version, so it might not have everything in it, but it's got all of the things that describe this cluster here in the YAML file. And there are additional fields that are just defaults. But basically, if you want to make a change to a cluster, you can either do it through the WKP UI, or you can do it here in the Git repo. You can make your change. You can pull this repo. You can make a change to the configuration for this cluster. Say for you want to change it to 5 nodes instead of 4. You can make that change here on the YAML file, check it in, and then it will be applied. WKP will still track it, so it still looks like any other change from WKP's standpoint.
Oh, I think we have a request in the chat. So let's see. Do you have? Oh, actually, so earlier on the show we talked about EKS tunnel or EKS control and how you can leverage that to deploy an EKS cluster. Could you maybe walk us through how one would go about doing so?
So on this cluster, so the WKP UI, it's not very dramatic, right? You've got this cluster listing on the management cluster, and you want to deploy a new cluster, you hit this create button, and then the dialog pops up that gives you the standard series of fields for an EKS cluster. You can define node groups and types and how many nodes are in the node group. Now, I generally don't do this because it creates a giant mess. And again,
Sure.
the demo gods are not always kind. So watching an EKS cluster spin up is usually not an exciting demo, but this is generally what it is. And underneath the hood, what this is actually doing is it's doing the same thing EKS Cuddle does. It's actually using EKS Cuddle to do that. And it's basically the same idea as EKS Cuddle, which if I were to cut over to the terminal, I think it's one of these two windows, so you'll have to bear with me while I tilt back. But basically, an EKS Cuddle command looks like this. I could be in the wrong window, but we'll see.
And if I'm not mistaken, you can also deploy you can also use EKS Cuddle to deploy a Fargate cluster too. Is that correct?
You can. EKS Cuddle has options. Oh, must be further up in my history. EKS Cuddle has options to define Fargate as one of the run engines for the cluster, so that you still need some nodes. So you can't have a cluster that's entirely Fargate. You have to have a control layer, and you have to have something that's part of that cluster. But in addition to that, you can make Fargate one of the execute engines for it. And I don't think I did that in my history, but basically an EKS Cuddle cluster command can be as simple as this. Right here, you've got a single line command that spins up an EKS Cuddle cluster. And I could scroll back up in my screen and you'd see that this generally takes maybe 10 minutes to run, but it's, I do this sometimes 20 times a day when I'm testing a change or I want to, deploy and redeploy an application because the thing that I'm testing is the deployment. You can run this like 100 times a day and, it's the same thing every time. All you change really most of the time is the cluster name and sometimes the region. And if you really want to be creative, you can have a different number of nodes. By default, it's 2, and that's usually for people who just want to try something out. But this is pretty much the simplest way to create an EKS cluster. It's a single command, and at the end, you have a cluster that you can interact with. You run this utils command, and it will generate a kubeconfig file for you. And you can either have it put into your standard kubeconfig file in your home directory, or you can have it create a different kubeconfig file, and you can use that with the -i field so that you can have a bunch of different ones for different clusters or different sets of clusters. That's really it. And underneath the hood, that's doing all the stuff in CloudFormation to set up all the infrastructure that you need to support your EKS cluster. You about to say something, Andrew?
Your
I
battery
was
is
about to say that, and I was going to say, I think EKS Cuddle is the only way to actually deploy EKS clusters now, just because it is so easy. So yeah, just all around solid tool, 100%.
I have done it through the console UI. I think at this point that counts as the hard way. I don't know.
Yeah.
But I don't think anybody really deploys Kubernetes clusters the hard way anymore because it is pretty heavyweight. There might be some people out there who are masochists, but
we did a stream with you all with a different host, me and Nikki Stone, one of my consummate co-hosts from a show called AM and Nikki. But the show started with me doing all the manual steps if you were to deploy it without EKS control, and it took about 20 minutes, not cluster time spin up, just to get through the steps. So the things that EKS
you mean
control
just
does,
reading it or just reciting them?
Going through each of the steps to actually, not even accounting for the time it took to spin the cluster up too in EKS, but just going through the steps, it was 20 minutes.
I'm going to display the help screen for EKS Cuddle here, just to make a point about, I think you mentioned Fargate a minute ago. You basically, if you want to start up a Fargate cluster, you want to add Fargate as one of your run engines. It's literally a flag, the EKS cuddle. You create a Fargate profile.
For sure.
And that's pretty much the simplest way that I've ever seen for someone to get into starting to run things in a serverless manner. It's not exactly like a serverless engine, but it's pretty close. And you find, especially companies that are offering services to other companies, and they want to make those services as scalable as possible, like they're processing incoming messages for whatever. That Fargate is one of the ways that they control their costs, so that they are not running a bunch of services they don't use when the service is slow, but still have expandability so that they easily and quickly scale out when demand starts to get high. It's a really great product, actually, and it makes that kind of really dynamic, very fast scaling pretty easy. So that's just an example, but there's a lot of options here. But that I wanted just to display that that's one, and that's one of the ones that was recently developed by the AWS development team at Weaveworks. Also, shout out to those guys. So, yes, that's what's happening underneath the hood when you click that Create Cluster button. This actually, I did this one this morning. This is a new cluster here that's running the latest version of Weave Kubernetes platform, like the bleeding edge latest release candidate build. It's not publicly available. It's a limited release right now. I don't think we've even given it to any client. But this basically is the newest possible version, and this is the cluster that it's running on, and this is an EKS cluster that I set up just to run within it, just to have something to click on, quite honestly. And it works out pretty well. If you click into the cluster here, you can see that it's got all of its components. It applied the model, and this is the branch that that I've connected to it in GitHub. This I think took me all told to set up those two things, and you could make this the way that you set up a new development environment for a new team. And you could have the whole environment running for them in the space of a couple of hours. This didn't even take me all morning. I spent probably half of the morning going over the presentation we were going to do today with Daniel, and the other half of it spinning up this instance of Weave Kubernetes platform. So just to cover a little bit more about what I mean by models, I'm going to take you through this. And again, this is the bleeding edge one. So if it falls over, it's because I forgot to sacrifice my goat. Ah, hooray. So these are models. And you can define models either by describing them as YAML JSON. So you can pretty much put any set of components in there. And this, by the way, is the last time we're tracking when models are changed or when models are created. That's all. It goes into your Git repo, so that's a commit, and you know when it happened and who did it. You want to add a new model, which I'm not going to do because, again, the goat, but then also just creates a mess. So let's give this, Andrew's model. And this model cluster, that needs to be updated, but still, we'll say that we're going to run Kubernetes 1.14 on it, and that it's going to run one node group of M5 metal nodes. I don't really know why, but another node group of M5 extra large nodes. And make this 30. I'm not going to hit the create button because I don't think I can afford to start 30 nodes. That would be my week's salary right there. Components and applications. Here you're listing the components that are going to go onto the cluster. In the cluster repo, that we just looked at, that's the components.js file. That's basically describing the set of components that you want to run on this cluster. So if you want Prometheus, if you want the alert manager, or if you just want to be able to export alerts to another monitoring cluster, you would define that differently. If you want to be able to use the Helm operator, and this, by the way, you can pretty much put any application in here. If you can express it as a Helm template, if you could express it as a set of YAML files, then you can put it in, you can describe it as a model, as a component, and you can make it part of your set of models that you can deploy automatically and describe as part of the cluster profile. Oops, I go back. Let's just say I'll select Redis and Prometheus and Alert Manager. So if you go to the next step, this lets you fill in variables that, again, they're defined as part of the component definition. So say, you want to define how many nodes you need in your Redis cluster in order to maintain quorum, or you want Prometheus to scrape every 60 seconds or every 10 seconds instead of every 30. Those are parameters that you can adjust to make part of the model. And then anytime you apply that model, those parameters are part of the definition. And in addition to that, you can decide that you want to add team workspaces to that. So team A and team B can be part of the same model, and you deploy them together. And I'm going to hit the X button here before I hit the save button by mistake and cause an earthquake or a flood or something. But that's the concept of models. The idea is there that you define what this type of cluster would look like. And then when you spin up an actual cluster, you pick the model, and you're effectively just reproducing the template for the entire cluster and all of the things and components that you want to run on it. There's a bunch of other things here. Policies, actually, I'm not going to click on because it doesn't do anything. But the policies in general that most application development teams and most organizations are talking about are usually the ones about who can do what at what time. Most of the time, that's best expressed as Git check-in rules. So that will happen in your Git repo. That'll be the restrictions that you place on branch merging or code reviews or anything like that. How are we doing? Do I still have lots of time? I like to talk.
Yeah, we've got about 30 minutes left or so.
There's a whole lot more to this. I mean, in general, those are your major features of Weave Kubernetes platform. It's designed to help you manage a fleet of clusters. In addition to this, you can have one management cluster manage other management clusters. So a management cluster can be a profile that you define. So say you have, data centers that are, you've got one in New York and one in San Francisco and one in Taiwan and so on. You can have a management cluster that manages a management cluster for each data center, and each data center has a management cluster that manages the clusters in the data center. I don't have a running example of that because that's extremely expensive for us to model, but we've done it for clients a couple of times, as long as they're willing to foot the bill. And it's actually a pretty powerful way to manage large sets of very distributed clusters that you're using for either application deployment, global application deployment, or supporting distributed teams who are doing development or operations in some way. So any one of these descriptions, any one of these deployments of WKP can be repeated and made into a hierarchy.
Cool. Yeah. So I don't think we have any questions from chat so far. Do you want to give us a kind of a nice summary to put a bow on it and just wrap up here?
Sure.
Hit the points that you think are most important about somebody who's brand new to the Weave Kubernetes platform, never touched it. What do you think would you tell a brand new person?
What would I tell a brand new person? You mean like a new developer or a new systems operator or their boss? Because those are three very different perspectives on what we're looking at, right? From a developer's point of view, this is how you can have control over the application that you want to deploy without needing to get access approvals to 20 different things. One of the advantages of access to this UI is you don't need kubectl. You would not be directly applying YAML files. You don't need a certificate on the cluster. You basically can just worry about your application and your deployment environment. Say you're working on one of those teams that has a team workspace, right? Using the team workspace, you just check in the YAML files that describe your service, and the YAML files that describe your ingress, and the YAML files that describe your pods and your deployments, well, your deployments really. And then you put them in the Git repository, and you let the operators worry about where they're going to run and how they're going to run. All they have to do is give you back the URL that lets you hit the application that gets deployed. From the operator's point of view, this is a way of giving the developers back responsibility for the things that they need to be responsible for, while also giving you the controls to keep them from doing anything totally insane, especially if they're going to be doing it in the non-prod environments, UAT, acceptance testing, or even prod. You then have the ability to approve things as they get promoted through the deployment pipeline, but you can deploy clusters on demand, and even in an automated way, because there's an API behind all of this. You can deploy these clusters in a couple of clicks. Say you get a new development team that starts up, some manager somewhere decides that one team needs to become two teams, one team of 10 developers, two teams of 5 developers, and they're going to work on 2 separate projects. Well, you can go into WKP UI and replicate the first team's cluster in another cluster, and immediately have that cluster running, because you've got a model defined that describes exactly how that cluster runs and all of its supporting applications. In addition to that, you have that trackable, auditable history of every change that was applied. So, a developer decides they're going to write new code, they build a new version of their application, that application gets deployed, and it falls over. Well, do you know whether that's your application code, or do you know whether somebody changed something in the environment that's affecting that deployment? If you don't have that history, then you don't know. But if you do have it, you can go and you can look at that repo, you can look at the deployment configurations repo, you can say, oh, well, you guys aren't deploying the right version of my image. It didn't update the image tag, so it's running the old version. That's why service A and service B can't talk to each other. Conversely, on the operations side, you have that full history. So if the developers checked in a change that says that they need a /8 subnet or something like that, like they want the whole 10 dot subnet, you have the ability to review that, reject it, and when things went wrong in the developer cluster, on the dev cluster, you can see that change was checked in by Sebastian Fernheim at 3 o'clock in the morning on a Sunday, and say, what were you doing? And don't do that again. And by the way, you're not allowed to touch our production clusters because you're clearly nuts. So you have the ability to enforce your rules, but still give them the ability to express what they need for their application, and then have it even deployed sometimes to safe environments where you feel like that's a reasonable thing. From the boss's standpoint, there's a whole other perspective. This allows your teams to cooperate with each other in ways that they couldn't before, and easily. The best thing about it really is that it enables you to get that whole environment running relatively quickly, without everyone having to learn every aspect of Kubernetes. Like, you don't necessarily have to have your developers need to know how to spin up a Kubernetes cluster. Even your operations people don't need to know all of the details about how to spin up a Kubernetes cluster. When they want a new one, they can go into the WKP UI, and in a couple of clicks, they've got a new cluster. So your operations people are less taxed. They're getting fewer manual requests from your developers. Your developers don't have to submit as many tickets, and your developers are able to get the environment changes that they need to deploy their applications without having to go through a long and onerous approval process. All that they really need to do is go through code review, have someone on the operations side approve their change before it gets, either deployed from dev to, testing or, whatever your policy is. But that becomes part of the normal review process that your developers are familiar with, and you don't have people on a call once a week, basically defending every possible change that they've expressed in a Word document, for example. It reduces overhead. It makes your teams more efficient. It makes both teams happier and more able to cooperate with each other. A lot of organizations have a big divide between operations and development. This reduces a lot of that divide, makes it more cooperative and less confrontational, less competitive.
Cool. That's